Hi, I'm Goldsmith, and this is my CS 2316 final project on the impact of international players on Big Five European soccer leagues. So the motivation behind this project was there are a lot of conceptions, both positive and negative, about international players on the European stage. Over half of the contributing players in those leagues are international, and the Premier League net spend on international players, which is just one of those top five leagues, was over 5 billion euros in just the last 5 years. Despite this money being shelled out, many of the game's greats, including Messi, Pele, and Neymar, have come from extremely poor backgrounds. So I wanted to see whether that was something that was generalizable or whether those were outliers. So my analysis goals for this included looking at individual impact on team success and determining whether team successes are correlated with their international players, consistency across categories and determining whether international players in Europe are distributed evenly across leagues and positions, and then also indicators of impact across nationalities, and determining whether indicators of poverty can be correlated with player impact. So for my initial data collection, I had a downloaded data set, which was just found on the World Bank data set website, and it contained info for every country in the world for over 70 different population metrics and poverty indicators. A beautiful soup web scrape from a website called FBref, which was just a reference website for historical soccer data, and this data set contained basic stats for every player to play in the top five leagues in the 2013 to 14 season. And then an API called the Sports Database, which the data I got from it contained info for every team in the top five leagues for the 2013 to 14 season. So for cleaning my downloaded data, I restructured the data set because it originally contained 15 years worth of data, which was formatted in a strange way. And I restructured the data down to just being for 2013, the year I was interested in. And then I filled the NaN values in the data set, which were originally just a string with two periods in them, and replaced them with np.nan, which made it a lot easier to drop columns and things when I was working with this data later on. For my beautiful soup cleaning, I matched some data types. Some of the numbers were listed as strings and had commas in them, so I had to remove these commas before I could even think about changing the data type of the column over to being a integer, which I eventually did. And then I fixed nationalities in this one too, where I dropped players without nationalities, and then there was a lot of formatting issues in this column, as well as the comp level column, as you can see here, and just in HTML. And so I wrote this line of code and this line of code to fix that. And then I combined all of Great Britain, England, Scotland, Wales, and Northern Ireland into one to match up with the data I had on countries from the downloaded data set. So then for cleaning my API, this was probably the most intensive part, was creating a dictionary of old to new team names, because there were a lot of discrepancies between my two soccer-related data sets. So I created this massive dictionary mapping the old team name to what the new team name needed to be, and then I iterated through it and replaced each one individually right here. And then I also added some attributes to the API dataset, including a list of players and international players for each team, and then points per game to account for the fact that different leagues play a different number of games. So my first insight was measuring prevalence of international players across leagues. I used scipy.stats to take an ANOVA test of all the data, which looks at the means of all five leagues, and this did find a significant difference in the average number of international players on each team. I then looped through all of the teams to find which leagues individually were different. I used ITER tools to do this, and then I performed a t-test on each pair of teams, which found that the only real significant difference was the Spanish league. So this is my first visualization in Matplotlib, where and as you can see here, while Italy has a lot wider range, Spain really is the only league that has a significantly different mean from the rest of the leagues in terms of the proportion of international players on its teams. So for my second insight, I wanted to test the correlation between the amount of international players in a squad and performance. This was probably my simplest insight. I just used scipy.stats to take a linear regression and found that there was a barely significant linear relationship overall between the number of international players in the squad and the performance of that team. We got a p-value of 0.038, which is a little close to 0.5 for my liking. And we can see that when I went back and did this test by league, I didn't get a significant value for any of them, meaning that I don't really think there's a super significant relationship here between the proportion of international players in a squad and their performance, and the squad's performance. So insight 3, I wanted to test whether international players had a greater individual impact than their domestic counterparts on just in terms of the raw numbers. So looking at goals and assists per 90 for attackers was the best way I found to do this. So I used the Penguin module to take a Man-Whitney U test which compares the distributions of two sets of data to see whether they could be randomly selected from the same data set or the same larger population. And it found no significant difference between the distributions of the two data sets, meaning that there really isn't a greater individual impact from forwards that are international. I learned and used Seaborn to make the visualization of the two distributions, which, as you can see here, shows that the two distributions follow almost the same exact pattern, just with a greater volume of players on the international side at the position of forward. Now, I was interested by this discrepancy in the number of players at the position of forward, and so I wanted to test whether teams gave more of their international minutes to some players to some positions than others. I used scipy.stats to take a chi-square goodness of fit test of these proportions, and it found that there was a definite difference in the proportion across position groups. This was the strongest result I had. Its p-value was so small that the Python actually reported it as being 0, meaning that we can say with basically 100% certainty that there was a significant deviation from equally proportional minutes to international players across position groups. So here you can see I had to split them up into their individual databases based on their position. The 5 positions I looked at were forwards, midfielders, defenders, fullbacks, and keepers, with the highest proportion of international players being forwards and the lowest proportion being goalkeepers. So my last insight, which was the most time intensive for sure, was to test whether major poverty indicators were predictive of team success. So I looped through every predictor that I had and first checked whether they had data for over 100 teams, which is what I did here, just to make sure that every team, that I wasn't going to have way too many NaN values for any predictor. And then I used scipy.stats to find the R and P values for each predictor. So the top 3 predictors I found were external debt stocks, total external debt stocks, school enrollment for secondary students, and total population. External debt stocks had some important countries that it did not have data for, which makes me think that this may not be super valid data for this one. These two did have data for basically everyone, but population total obviously is not really a poverty indicator. It's just mostly a control, which means that I don't think we can really say from these insights that there were super strong ties between poverty indicators and team success. Here I've graphed out using Matplotlib the correlation coefficients of major poverty indicators. So we can see that the largest one here, which was this outlier, is only 0.44, which is not a super strong correlation. About half of the p-values for these were bunched under 0.05, but considering that it was only half of the poverty indicators and some of those were just controls, I don't think we can say that there's a super significant correlation here. So conclusions from my analysis on individual impact and team success based on insights 2 and 3, the conclusion I drew was that having international players may correlate with team success slightly, but not super strongly, and individual performances do not correlate at all with whether a player is international or not. Consistency across categories can clearly be seen from insights 1 and 4 that international players are not evenly distributed across leagues, with Spain having significantly less, and not evenly distributed across positions either, with forwards having by far the highest proportion of international players. Lastly, indicators of impact across nationalities based on insight 5, poverty indicators do not seem to correlate well with team success. So challenges in learning. Phase 1, finding a downloaded data set with enough poverty indicators was a big struggle for me. I finally found it, but not until I was working on phase 2. Phase 2, I found that I couldn't call web scrape datasets in the downloaded cleaning script, which was tough because I was trying to do some combination stuff there. In phase 3, my 2 web scrapes datasets I think may have been a little too similar, which made it hard to find quite enough insights, I think, although I think in the end I got there. Things I learned, I became far more comfortable with than I previously was with pandas and data frames, just from how much I worked with them. And then I also learned to use 2 new modules, Seaborn and Penguin, and I brought myself up to scratch on a couple of modules I knew in the past in Matplotlib and SciPy, but hadn't worked with since this last summer. Thank you.